Hello, everyone. Our group's project was on the evolution of Winter Olympics by the exploratory data analysis, and it is made by Brandon, Ekin, and me. Our group's motivation of this project is basically we think the Olympic Games is a platform that reflects the performance and determination of the contestants. And in this project, we will be going over 4 research questions regarding the Winter Olympics, which will cover the analysis on individual athletes, but also about the factors outside from these Olympics. Okay, so for our research question 1, we aim to analyze how does the curling and the hockey team's average age compare, and how does it affect the score of their disciplines in the 2022 Winter Olympics. And the method we do that is we calculate the average ages from the date of birth, and we have a calculation on the overall performance from each match. And after we obtained both ages and the overall performance, we plot the performance represented by total net score versus the ages. And here is the result we got for net score and average age. And here are just some highlights. We can see that the points ranges from positive 40 to negative 40s. And the average ages ranges from 24 to 38. And from figure 122, we can see there is no clear trend between the ages and net points. And we think it's more or less expected because the curling requires more techniques and experience rather than just physical fitness. And we did a similar thing for hockeys. And here's our result for net score and average age. And some highlights. The net points goes from negative 40 to 60 points. And the average ages ranges for just above 24 to 30, which is much narrower compared with the range of ages for curling. And again, there is no clear trend between the ages and the performance. So our conclusion is that age is not dependent on how well the team perform, but the hockey athletes are generally young because we can see the data points are mostly gathered around the left-hand side of this graph. The athletes are generally young enough to be physically competitive. And for our research question 2, we talked about how the percent of athletes that gained multiple medals in all the events after 1980 among all athletes that win medals, and how does this data change over time. And the method we do that is we using scraping to obtain all the data sets needed. So, and then we calculate the percentage of the athletes that gain multiple medals. So, and then at the very end, we create a new data frame that stores the percentage along with the corresponding years of the events. And then we plot it. And here is the result we got. We can see the data fluctuates between about 13.5 to 19% between 1980 to 1998. But after that, there is a clear increasing trend from 12 to 18%. And our interpretation of that is that winter sports is becoming more popular. And so the competition of the athlete selection is also becoming more fierce. So for standing out from other competitors, there will be an increasing number of athletes who will be trained for multiple disciplines. So therefore, there will be an increase in the chance of getting multiple medals. And that's all for my part. For the next section, I will hand it over to Iki.
Right, now let's move on to research question 3. Is there a correlation between the hosting country and the increment of the number of medals? We're cleaning the data set and also calculating the average medal count for each country when they're being a host and not being a host. And we're calculating the percentage difference by using the equation and also plot the trend for each country to compare the results. As far as the percentage difference, we can see that most country has a positive result. So it can give us a conclusion that there is a positive correlation between being a hosting country and incrementing their number of medals. However, as we look at the graph, since it's only for each country and the data is being fluctuated as it's not showing a growing trend, so that it's kind of hard to derive a result from just looking at the plot, because there are such reasons like the year of hosting is too early or the country's lack of talent, athletic talent. So it's better for us to look at a statistic result instead of the plot result.
In the research question 4, we figure out how does a country's GDP predict its medal count in Beijing 2022 Winter Olympic Games. At first, we merged the 2 data sets we needed into a new data frame for modeling later. And the features are just a GDP growth rate of the previous 3 years. And the label is the medal count. After data manipulations, we used all the historical data as a training set, and the statistics in this year's Winter Olympics is our testing set now. And therefore, we feed 2 models, which is data training regression and the random forest regression. And this is the results of our predictions. We have 2 predictions from 2 models for each type of metal. And This is the mean square arrows table, and we can find the random forest have smaller arrows than the decision trees. So we make conclusion that the random forest can make better prediction. So in the future, we focus on how to address all some limitations of our research. So the first is in the research question 1, the method of over-evaluating the teams might be biased. So a better method for summarizing the relative performance among these teams can be explored further. And in the last research questions, the errors are relatively higher than we expected. So one reasons could be the pandemic and makes most countries have negative GDP growth rates. And on top of that, the countries are quite different. So we just use some countries' data to predict another countries, which cannot make sense to some extent. So in the future, we can try concentrating on predicting one or just a few countries.